Right. All right, here we are. Once again, it's 2 hours UTC, and it's time for Astronomy Daily Live. So this is just a casual daily get-together, most of the time daily. Sometimes, I'm called away, or there's things that I've got to get done. But all right, very
sorry
very cool.
about that.
Very cool. Anyway, so yeah, this is just a casual get together each and every day amongst an ever-growing group of friends, sort of like a virtual porch, or maybe like a virtual campfire. And it's sort of the end of the day. We're just sitting back. We've grabbed our consumable of choice, which in my case is hydrogen hydroxide, HOH. It's very, very relaxing, very awesome, pretty incredible molecule. And I've got a few of those molecules in here, probably something like 10 to the 24th of them or so. That's a 1 followed by 24 zeros, just in this little tiny little thing.
That's a lot of zeros. Yeah.
It's a lot of stuff. We've decided, to sort of subdivide things up into these little pieces, and those molecules even aren't the smallest things, right? And there's tons of them in there. Anyway, cheers. I'm going to enjoy a few of these.
I mean, there's my picture of my hat.
Oh yeah. All right. So let me introduce the panel once again. So here's Earth Radio. Nice. So
show you the mug.
Is this who's making these?
I am.
Oh, very cool.
I mean,
nice.
I ordered them. I'm that one there comes from Vista Print, I think.
Okay, yeah. I've heard of them.
Yep. So let me.
Yeah, in fact, my business cards. Oh yeah, let's look at your mugs though first. Earth Radio, because
it's just one mug. It's just one mug.
Well, it's double fisted. Right?
Yeah, it's double-sided. Yeah, so you got one. So no matter what hand you drink with, you can always see the image. Okay.
Nice.
And so it says Earth Radio, and it said because we can. That was Johnny United's idea.
Right.
And then all right, of course, is my phrase.
All right.
But that's why we have those 3 sayings on there.
Nice.
And so then, of course, the icon of the little red button with the Earth Radio, that's Andy Morrow made that one, actually.
Cool. Yeah. So remind me and remind everybody what ERRT stands for.
Okay. Earth stands for Epic Reality Radio Tour. What that means is that I can have, as long as somebody has internet service, like if you go to a restaurant or you can go to a coffee house, go to a church where you can connect to the internet, anywhere you go, to the mall, if you can get internet, and you got a good signal, I can do a radio show right there.
Nice. Yep.
So the term epic, meaning anywhere at all, I could be doing an interview with you. I could be doing a radio show. Whatever, we wanted to play.
On planet or off planet, right?
Yes, exactly. And Andy shared a really nice picture that he got from somewhere else. And he got a, what is that now? I have that turned down. Okay, that's not me. That's weird.
I don't know what
that is. Who is that? I don't know. I got to get that turned down.
Oh, I think it's the mischievous fellow panelist here that is intruding on our private conversation a little bit here.
So anyway, my goal is of course, not only can I go everywhere and have a show, I can actually share my show with other people, which is what's happening now. You
Oh,
know,
very cool. Very, very
like we
cool.
just had Chris Elliott do a show, you know, and we have Total Brian doing a show.
Right.
And then we have Keith X that will do a show. He's from P&K Space Imaging. And he'll do his own little mashup song stuff that he does with turntables and everything, you know.
Nice, nice,
And
nice.
then we'll have Amanda. Of course, she does 3 days a week. She's in Canada,
Yeah.
and I'll get to meet her this year at Pine Bush event.
Oh, sweet.
And then Charles is my co-host. I don't know if you talked to Charles at all. He's my co-host on some of my talk shows. But
Cool.
Andy, the one that did the little red logo there on the cup, he's actually in UK, and he does his own shows from the UK.
Nice.
So again, another form of saying the term epic,
Right.
epic reality radio tour. If that that makes sense, I think now.
It makes absolute sense. And speaking of epic, I definitely want to say howdy too. Bobby, what's going on? See, now that he's got the spotlight, he's speechless.
See now, Keith X, he did something for the World Wrestling Federation. He did some kind of music thing before the show started on this weekend.
Oh, okay.
And because he's a DJ, anyway, he's a DJ. But
right, very cool.
Yeah, so he did that. But I'm honored that he's on my team and he plays on Earth Radio occasionally.
Yeah,
and of course,
awesome.
when Bill is done with his busy transition of summer and everything like that, he'll be able to play some more music shows on Earth Radios too, as well. And Bill is a producer of another radio station. So,
right.
So that's a lot of fun to have these people involved.
I would definitely like to get involved. I just need to not spread myself too too thin because that's a.
So we are a newcomer watching me, watching you. I think if P&K is still on, you can go there.
Yeah.
Yeah. I was going to say, if you wanted to do a couple of tester shows, whether it just be you and I just talking or whatever, it can be something like this, or we can use Skype and go on YouTube or whatever you want to do.
Sure,
however you want to work that.
I've got a couple of ideas, but like I said, you know, I don't want to spread myself too thin.
Like I have Eric Hartwig. He's the Massachusetts MUPON state director.
Right.
Okay. And so he's basically the head investigator for Massachusetts. So
gotcha.
I explained that before. If you have a UFO sighting in Massachusetts, and you call Eric, and he's the one who will investigate it. Okay.
Very cool.
So
nice.
I know him personally. He's a good friend of mine. And he comes on once a month on the last Thursday of each month. And we're trying to extend that a little bit, but his schedule is a little bit varied.
I don't think Mark Antonio is on as well. I don't think so.
Oh.
Yeah, I'm not sure if he's on or not. Anyway, definitely wanted to say howdy to everybody in the chat as well. Let me see. I've got Carolina Sky Astronomy. Hey there, Jim. Nice to see you. Uncle Bill, of course.
Uncle Bill, yeah.
Who let the nerds out? Hey, we are everywhere.
That's right.
We're everywhere. We are running the show.
And get used to it.
Get used to it. Absolutely. Absolutely. And watching you, I like that name. And welcome. Welcome. Yeah. Thanks for coming on over. We're talking astronomy here. Speaking of astronomy and space and all that kind of stuff, I definitely wanted to let you all know of two things that I think are going to be happening in the next few days. The first is a a spacecraft that is currently, well, it was launched aboard a Falcon 9, SpaceX Falcon 9, about, I don't know, maybe a month and a half ago or so. And this spacecraft is built and run by a company called SpaceIL. And they are just a couple of days away from landing on the moon. So they've been slowly getting out there. They've had to make several spins around the Earth, to sort of fling themselves out. Each spin, they give themselves a little kick, and they get further and further out until the moon can capture them. Well, they went into orbit around the moon a few days ago, and they are planning to land on the moon on April 11th.
And this is American? This is American? Or joint?
No. This is a private company out of...
And we'd like to welcome James Dugan in the chat.
Yeah. Hey there, James. This is a private company out of Israel. They were part of, or participants in the now dead Lunar X Prize.
I actually think that they've been going back ever since. They just never publicized it. I think we've been doing more on the moon than they are telling us. That's just my suspicion. It's not a big deal if they are or
I don't know what the big deal is either. I don't care. I'm
fine if we are. It would even make it more sensible to me that we are. After all this time with the technology that we have, why wouldn't we?
Right. Well, like I was saying the other day, I've been privy, to some secret things, and
we're at the welcome Unbox Warehouse.
Unbox Warehouse. Right. Hey, nice to see you. And those secrets. My response was, it's like, really, that's kind of dumb.
Yeah.
So I think a lot of secrets or classified things are like that. It's like, why? But who cares? And so anyway, they're going to be landing hopefully in a couple of days. So definitely keep an eye out for that. So I think
this is a manned, or is it just an unmanned probe?
No, it's just a lander. It's just a lander. I think it's got some scientific instruments on it. I don't remember exactly what they've got.
I want to find out if it rings like a bell when they land.
The spacecraft or the moon?
No, the moon. If the moon rings like a bell. Some people try to claim that it's hollow, and we got there's some kind of situation where somebody's keeping tabs on us from the moon. They got all kinds of equipment inside the moon, and they got and it's hollow, and it's like, okay, whatever.
Yeah. I think it's extremely important to keep an open mind about those kinds of things. There's this there was this outrageous idea about humans flying, flying like a bird.
Yeah.
It's like, that sounds a little crazy to me, right? But here we are doing it, and it's routine.
And the first flight was, of course, the Wright brothers, which was documented.
Yeah.
I think there were other flights before that, but they weren't really successful, or they weren't long enough, or whatever.
I think too, you have to specify powered flight,
right?
Because I think that there were like gliders and that kind of stuff.
Mm-hmm.
I can't be absolutely sure about that.
And well, on box we have set tire of the SpaceIL Falcon Heavy launch video. If you can, I can okay your link if you can give it to me, please.
And speaking of, yeah, go ahead, Unbox. You can post that link, and
I wonder what's in his box. If he's unboxing, what's in his box?
I don't know. I don't know. Anyway, speaking of SpaceX, that's actually the second thing that is going to be going on. Hopefully this week also, the second Falcon Heavy is going to launch. I think right now it's scheduled for the 10th. So that is just in another day or so, day and a half.
What is the difference between the Falcon Heavy engines and, say, the space shuttle engines?
In terms of power?
Yeah, and size, maybe.
I think the shuttle, you know, full thrust on the shuttle was I think more than Falcon Heavy. I don't have that info in my head. So
what about the Saturn V rocket, which was supposed to be the biggest engine?
Yeah, I think Saturn V is still has still, you know, the largest punch.
Okay.
So far. But yeah, you know, the Falcon Heavy is basically just 3 Falcon 9s all bolted to one another.
Wow.
So it's 27 engines, and they're actually going to try to land all 3 of the first stages. You know, they launch the Heavy, and I think a couple minutes after launch, the 2 on the side, they come off.
Mm-hmm.
And then a little bit later, the center one comes off. And so I think the plan is to land those 2 on the side back on land, and then the center one they're going to land somewhere way out in the ocean. It's like 900 and some kilometers.
Yeah, see, they've been landing the 2 stages, first and second stage. I think they've been landing them on the platform in the ocean, right?
Yeah.
And that's
absolutely
incredible. That's incredible to see that happen. I mean, when they come out of the orbit of space, you know, here they are landing back on this little target, you know.
Oh, okay. Well, let me correct that a little bit, Ron. Those rockets actually never.
They didn't get out. Okay.
Yeah, they don't. It's just a parabolic. They go. You know, maybe technically, you know, they get into space. You know, they might get like 100 kilometers up. Maybe. Like
a stratosphere.
Yeah, I mean, they're pretty high, right?
I would have to look at that launch and see how they did that, and that would tell you. So.
Yes.
But, yeah, that's cool.
Yep. Yeah.
But just imagine, though. Just imagine that rocket, the stage goes back and it lands on that precise spot.
Mm-hmm.
And we couldn't do that 10 years ago. We just didn't have the technology.
Well, you know, it's a combination of sort of the technology and the know-how, because you know, the hardware has to work, but there's some amazing software that is running that thing.
Oh yeah.
So yeah, I think it's absolutely amazing. Now, Blue Origin is also going to have a reusable first stage, and they are also going to land on a platform in the ocean, but that platform is going to be moving.
Oh, okay.
So they actually think that it'll be easier to land on that, mainly because, you know, the motion, I guess, makes the
It's in line.
platform
Yeah.
much smoother,
Yeah.
right? When you have a platform, that's just sort of
So
sitting
Falcon
there in the
Heavy's
water.
launching tomorrow, huh?
Who's launching?
The Falcon Heavy's going to be launching tomorrow, huh?
I think it's planned for the 10th. I think. I don't think that they are going to be able to get off on the 9th. I think the weather's going to be bad. So yeah. Very cool.
I'm about to watch Unbox video right now.
Good. So Unbox, that is very awesome. You are a lucky person. I have never ever seen a rocket launch at all. I see, I'm located down in southern Arizona, and so when I look east, I can see the suborbital launches out of White Sands. But it's not the same thing as being there. So at some point, I definitely would like to see a launch. I like the fact, that SpaceX is throwing a few things out from Vandenberg. That's a little bit closer. Oh, that's right. James Dugan, he points out that what is it? The dark. No, the Event Horizon Telescope is supposed to make some kind of announcement tomorrow, the 10th, about their results. They we talk about black holes, and black holes are still mathematical figments of our imagination, right? We've never ever seen a black hole. We see that there is something happening to the material around it, but we've never actually seen this thing. And so yeah, there's supposedly some kind of announcement that's going to be made about taking an image of this thing, and this is the so-called black hole that's right in the center of our galaxy. It's a really big challenge to see the center of our galaxy, because it's being blocked by dirt and dust and gas and stars and all of that. So it's really hard to see it. It can be supposedly seen. So yeah, we will have to see. What is said there. I don't know why, but I've got this suspicion that it is going to be maybe a non-event. But I don't know. That's me being a skeptic. So yeah, I'm thinking that the best that they're going to be able to say is that it's like, well, we sort of think that we see something, but maybe not. I mean, I love surprises, and so I would be absolutely.
But didn't they see on in one of the galaxies? I can't remember which one. They had evidence of a black hole discharging some material.
Yeah, they there's a lot of activity around these objects for sure, but what they really are and what they're doing, I don't think anybody knows. And yeah, so it's still a great mystery. So Astro Live channel, hey, nice to see you there in the chat. Cheers. So yeah, just a lot of things going on, space-wise, at least. So yeah, you know, it's never a dull moment at all when it comes to space and astronomy and all of that. You know, I definitely don't try to chase the news or anything. You know, when I hear things, I like to talk about them, and that's about it. I'm not a reporter. I'm not any kind of you know, trying to get you know, the latest news on all these things and all that kind of stuff. But you know, when I hear about, you know, some cool things, and I definitely think that landing a spacecraft on the moon is just you know, really epic, right? I mean, that is just absolutely fabulous. And you know, these Falcon heavy launches are also epic because they're just so big, right? These big, massive machines that you know, are moving, you know, thousands of miles an hour. It's just you know, it blows me away. Let's see. I'm looking at James Dugan's comment here. I think there's a jet coming off of it. Yeah. It, you know, it is definitely a very dynamic place, and with the help of technology like the adaptive optics, and also observing in the infrared, we can sort of see through all that stuff and get some really nice sharp images. And what we see over time is these stars that are orbiting, and sometimes very rapidly, some kind of object, some kind of unseen object. That's the thing that really puzzles me a lot. Is that, you know, we can see these stars that are very clearly, you know, quite close to, you know, the center of the galaxy. You know, quite close. I mean, I'm talking, you know, I mean, I think these orbits for some of these stars are in the years. So you know, I mean, we're still talking, you know, many astronomical units, but that's really close. Yet we can't see the object that they seem to be moving around. It just seems a little strange to me. So you know, there are things going on there that you know, I don't know if we understand completely. You know, maybe a black hole is black, right? And you can't see it because it's black. I don't know. You know, I think the theory, and you know, these are models, these are mathematical fantasies, say that, you know, a black hole with this mass in this kind of environment should look like this. And when we look, I don't know if we're seeing that or not. So yeah, I'm kind of curious to see what the Event Horizon Telescope group is going to show. And I think, James, you may know this, because I don't remember and but I think the Event Horizon Telescope, I think, is that a series of radio telescopes, or are they like infrared or optical?
Yeah. And hey, Astrolot Channel, sorry about not responding soon. I was actually watching Unboxed Warehouse's video about SpaceX and stuff like that, and I think that's pretty darn cool.
Yeah, I will definitely
And
have
at
to
Unboxed
take a look at
Warehouse,
that.
you consider yourself subbed in bail by me.
All right, well, cool. I am definitely going to check that video out too after the live stream here. I don't want to.
That's why I mute my mic though, because it's going to be loud and stuff.
Yeah. All right. I've got the video queued up here, so as soon as we're done, I'm going to hit that play button and take a look. But yeah, I don't remember what the details are of the Event Horizon Telescope. If they're radio telescopes or optical or infrared, I'm not exactly sure. And yeah, you know, I'm looking at the comment about the OSIRIS-REx spacecraft, and the fact that Bennu seems to be throwing off stuff. And in fact, I think it was maybe about a week ago, or maybe it was a couple weeks ago, we actually looked at a research note from the AAS that this person had actually gone so far as to predict when we will see meteors coming from this comet. And he actually made up a list of did we? Oh, you know what? I don't think I actually ever followed up on that on the live stream here. I posted our conversation to the Discord channel, but I don't think that I ever talked about that. So let me back up a little bit, give you a little bit of a backstory, and then we'll take a look at the responses. So we took a look at this paper, like I said, I think it was a couple weeks ago or so now, predicting that we would definitely be able to see some meteors from Bennu, the asteroid, as a result of all these particles flying off of it. And this person had run some models and found that the Earth and this path of particles, the asteroid is going around the sun, and so it's spewing off all of this stuff and leaving this path of rocks and dirt and dust and the Earth can and will pass through that path, and that's how all meteors supposedly
Here's a
take
good
place.
question: does astronomers love to flatulence?
I think that astronomers are pretty conservative when it comes to that. Yeah, I've spent many hours in observatories, and that was a pretty rare occasion. So yeah. Anyway,
I just thought about popping that up because I may have inadvertently did a rip.
Well, you know, those kinds of things happen all the time, and we should not be in any way embarrassed or, you know, shamed by anything that these pretty interesting and amazing bodies do. I think they're pretty amazing. So yeah, rip away. But looking at this short paper, I had some questions. He you know, he posted a table that in the text said that, you know, here's a list of all the meteor shower events that were going to take place between 1900 and 2100 AD, right? The year. And when you look at the table, well, there's nothing before 1991. And then it goes from 1991 to 2014. And then from 2014 to 2099, almost every year. And I'm like, well, why don't you show all the other ones? And so I actually told everybody here, you know, that I was going to email the author and ask him exactly that. It's like, what, you know, where's all the data, right? And so that's exactly what I did. I don't know if you recall this or not, but I did predict that and I know for an absolute fact that you know, authors don't really think that anybody actually reads their stuff, and so when they realize, you know, that people are, they're absolutely thrilled. And so I'll show you. Let me grab the Discord here. There we go. Now I'm trying to remember where I put it. Let me look around here really quick, because it's actually been a little while, and I meant to actually talk about this much sooner than what I did. But let me see if I can find it here really quick. Here it is. Okay. All right. So, all right. Let me share my screen here. Do that, and then I'm going to do that, and then I'm going to do that. Bam. Go to infinity. Go down the black hole. See, there's a black hole right there. See, a wormhole right there. I love it.
There
okay,
it is, right
so
there.
Yeah, there we go. All right, so here is
right down there.
Yeah. So here's what I wrote the author. You know, you just basically, you know, saying exactly the same thing, you know, that I just said now. And here's his response. This was on the 1st of April. So yeah, that was a few days ago. Anyway, first line. Thanks for your interest. See, they love that. And so here's the answer he gave. Let me zoom in a little bit here. Oh, that might be a little bit too much. There we go. So even though he ran this model from 1900 to 2100, the first encounter was actually in 91. And yeah, those are just so that list is confirmed. So yeah, according to the model, that's exactly what is going to be going on. Now, we are definitely not going to get any kind of meteor shower. These are extremely slow moving things, relatively speaking. So even large objects. I think in the paper he was talking about centimeter size meteors are only going to get like to sixth magnitude, which is just barely on the edge of being able to see them with the naked eye. So these are going to be very faint meteors. We normal folk just are never going to see any of this stuff at all, and you're not going to lose out. So, but I actually asked him a follow-up as well, which is here. So, and that is, would we be able to observe these? And his response is that well, yeah, given the right kind of instrumentation, we should be able to see them. So I actually didn't look into the CAMS network here, so I'm not exactly sure what their detectability is, but he thinks at least that these folks might be able to see a few of those, and so yeah, I think they should definitely look. And yeah, basically I just wanted to follow up on that, let you know that you can get a hold of these authors. They put their the addresses right there on the papers. So if you have a question, email them, ask them. They, like I said, they're usually very thrilled, that somebody is actually reading their paper. It takes a lot of effort, a lot of work to write these things and work out all the details. And at least in this case, he's working with a model, and so it's a lot of work, even for a very short paper. And so yeah, I think that they greatly appreciate realizing that their stuff is being read, paid attention to. I do think it's very intriguing that asteroid is shooting stuff off into space. That surprised everybody, and I think that's great. Being a scientist, I love surprises. I love those kinds of things. So yeah, we're going to have to understand that a little bit more. And we have a spacecraft there that is going. It's not going to be there forever. This is a sample return mission. So the OSIRIS-REx is actually going to. It's not exactly going to land, but it's going to get really close, and then it's going to extend this arm out, and it's going to touch the surface. It's going to make contact with the surface, and hopefully grab a bunch of this dirt, and then they're going to put it into this special capsule and fly it back to Earth. So yeah, the OSIRIS-REx isn't going to be there for a really long time, but I think it's absolutely fantastic that they have made a discovery, which was, I think, pretty unexpected. So yeah, I think that's absolutely absolutely fantastic. So I'm just I'm trying to catch up in the chat here. Yep, giving off particles. Absolutely, absolutely. Hey there, Ingrid. Nice to see you in the chat.
Welcome, Ingrid.
Yeah, welcome. Glad you could come by. So, speaking of the research notes of the American Astronomical Society, I glanced at the latest ones, actually right before this live stream, and I noticed, you know, sometimes, you know, I sort of start to look at these things, and I start to dive into them a little bit, and it's like, wait, you know, let's do this on the live stream. You know, let's not do it here. You know, let's wait. So oftentimes I will see an extremely intriguing title. It's just like, wow, what is that all about? And that actually popped up here. So why don't we take a look at that? Let's see, where am I going here? Gotta share my screen again. Gotta hide that away. Come up here, and so let's go to the research notes of the American Astronomical Society. So these are just like really short little papers. They go through a very short review, but there's no, you know, like peer review or anything. They just sort of do a like an editorial review, make sure the spelling is right, and you know, make sure that it makes a little bit of sense.
Do we have the radius of the Habasa 2, or no, instead going to RNS?
I don't know what that means. Hayabusa 2. Oh, okay. So Hayabusa 2 is the Japanese probe that is currently around the asteroid Ryugu, which is
Lord.
I'm
sorry about that. It appears to be my garbage boys just finally just picked up garbages.
Well, congratulations. At least it's getting done. I've got to take mine. I've got to do my own here. So yeah, you know, feel lucky.
What about that spacecraft again? I just got distracted by the garbage.
That's all right. Yeah. So yeah, the Hayabusa 2 spacecraft is currently right next door to and exploring the asteroid Ryugu, which is extremely similar, scarily similar to Bennu in both size and shape and characteristics. They're like twins. So yeah, they're actually, the Japanese are doing pretty much the same thing. They've actually gone down, I think, twice and grabbed some stuff off the surface and collected it. So I don't know exactly what the status of that is. So yeah, we'll just have to keep our eyes peeled for news on that. But there were a couple of papers in here that I found kind of intriguing, and it's these first two. So this one is talking about future stellar flybys of the Voyager and Pioneer spacecraft. So of course, Voyager and Pioneer are flying out of the solar system. you know, not well. It's sort of a relative thing, but not really fast. I think they're supposed to reach the distance of the nearest star in something like 40,000 years or something. So you know, I mean, they're still moving pretty darn fast, but space is really big. So I mean, it takes a long time, you know, to get anywhere. But these folks apparently have been doing, you know, some kind of projections to see where these spacecraft are going to go. Now, I sort of thought that was sort of a known thing. That it's like, okay, you know, Voyager's going to go off that way, and Pioneer's going to go off that way, and we're all done. But here's
what is the nearest star?
The nearest star, besides our sun,
Right.
is
exactly.
is Proxima Centauri, and that's about 4 light years away.
Okay.
Yeah. So you know, I mean, so you know, traveling at 1% of the speed of light, it would take you 400 years to get there.
Oh wow.
Yeah. So
by that time, the Voyager spacecraft will be out of gas and we'll be getting information.
Well, that is absolutely true. They, you know, Pioneer is dead. It's just zooming out, right? I mean, you know, there's no communication at all. Voyager, I believe both of the Voyager spacecraft are still in communication with us. It's extremely low power, you know, but I think I think that it has enough power, both of those spacecraft, to, I think, you know, continue to send us back information another maybe 10 or 20 years. I'm not exactly sure, but I thought that it was sort of a done deal. What's going to be happening to these spacecraft over the next, you know, 10, 20, 30 thousand years, you know, but so I'm kind of curious to know what they're even talking about. So let's take a look. Future stellar flybys of the Voyager and Pioneer spacecraft. So let's see. So of course, you know, they did most of their exciting stuff long ago now. In fact, the last encounter with Voyager 2 was back in 1989. So wow, that's 30 years ago, right? So yeah. So let's see. So although they're going to cease to operate long before encountering any stars, it's interesting to ask which stars they will pass closest to in the next few million years. So they took the 3D positions and motions of a bunch of stars, 7.2 million of them, looked at Gaia, which we have done here many times. Gaia is a huge database. It's got I think about 1.8 billion stars in it, and it's got the positions, it's got their motions, it has their distances, it has their colors, their brightnesses. Some of them have temperatures. Lots and lots of information. So these folks have taken you know, the 3D positions and motions of 7.2 million of those stars, and try you know, to figure out if if the Voyager or Pioneer spacecraft are going to be going by any of these stars in the next, few million years, it says. So pretty cool. Let's see. We adopt the same method we use for we determine the asymptotic trajectories of the four spacecraft. So I think we've actually used the Horizons system before. So very, very cool. It's nice to be using the same tools that the major institutions use. So let's see, they're propagating them numerically to the year 2900 and then extrapolating out. Okay. Linear motion. So, right, once, they're basically assuming linear motion, that there aren't going to be any things that are going to change the trajectories of these spacecraft. And I think I suppose that's a reasonable assumption. We don't know what stuff is out there if we can't see it. So
It's like 900 years from now.
Yeah. Well, and that's just taking into account sort of the calculated motions. After the year 2900, they sort of give up and say it's going to be going straight out that way. So let's see. So using
I could see them about 2027 or 2800, and then they get a message back from one of those.
Yeah.
Like, what the heck is this?
Yeah. What is this thing? Yeah.
We forgot about that mission like 400 years ago.
Yeah. So let's see.
Think about the back pay. They'd have to pay everybody back pay for all that.
I know. Wow.
400 years back pay for all that.
Nice. Let's see. So linear motion. Identify the stars which approach within 15 parsecs of each spacecraft. So that's kind of interesting. Like along the path of these spacecraft, about 4,500 stars pass within 15 parsecs of the spacecraft, which that seems a little far, right? I mean, a parsec is about 3.26 light years, so we're talking about 50 light years. But
now would that be interesting though, if we could create a engine or a space flight that could meet up with those ships, before they get to that point?
Yeah, who knows? Who knows? It's that is definitely going to be a challenge. But I think my observation about humans, and I think a lot of things in general is that if we want to do something, we probably are going to be able to figure out a way to do it. I don't know. That's a tough nut. Space is really, 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 really big, and so even moving really, really, really fast through space still takes or can take it just an enormous amount of time. So who knows? Who knows? Okay, so here's some interesting encounters. So Proxima Centauri, that's kind of interesting. um, trying to understand this this table here. Wow, I don't know if I'm getting this or not. Let's this is, you know, this is the process that you have to go through in order to understand these things. You look at the table, it's like, oh, I don't get it. So, you know, let's look back up in the text. So
looks Spanish to me.
yeah. No, you know, I think that anybody can really understand this stuff. It just takes a little bit of time and you know, a little bit of mental gymnastics at times, but I think anybody can get this stuff eventually. So let's see. Proxima Centauri is the first flyby in 3 cases because that star is the nearest neighbor. Oh, I see. Okay. So yeah, they are looking for stars that Voyager is going to be passing by within 50 light years. So of course, Proxima Centauri is going to be on that list because it's only a few light years away, 4 light years away. So okay, that makes sense. Now let's see what else we've got here. We've not considered acceleration. Okay, the accompanying data tables list around 10 encounters, closer than 1 parsec per spacecraft. So let's see if we can make some sense out of this thing here. Very bright stars like Sirius and Alpha Centauri are not in the Gaia data release 2 because they're just too darn bright.
Good night, James.
Good night, James.
Good night, James.
Yeah. Good night, James.
Thanks for coming in. Thanks for coming in for sure. So, dang, I'm still okay. So here's the spacecraft, Voyager 1. Here's the star name. All right, so Proxima Centauri. Here's another star. Here's another star. Here's another star. Here's another star.
What is the number so next to that where it says medium and it's 16.7? What does that mean?
Yeah, this is what.
That's what I'm getting confused on.
Yeah. Okay. So here maybe is a little thing here. So for each spacecraft, the first and closest encounters are shown in the first and second lines respectively. So Voyager
16.7 light years. Is that what that's saying?
No, this is in thousands of years.
Oh wow.
So I think this is saying in 16.7 thousand years, Voyager 1 is going to pass closest to Proxima Centauri, and it's going to be about 1.072 parsecs away.
Mm.
I think that's how you would read that. I'm not quite sure what this 5% and 95% is. It seems to be some kind of a limitation, right? Minimum and a maximum of some sort. So, yeah, that's probably what that is. Is that, you know, they can't really predict, you know, the motion extremely well. So it's going to be, you know, between 16.5 and 16.9 thousand years from now. So that's kind of cool. And then it looks like it's going to be passing by this star, TYC, blah, 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 and it, like in about 300,000 years.
Oh, wow.
And the distance is going to be, what, about a third of parsec, about a light year away or so. Let's see if we can see what these other things are, because this looks like a velocity of some sort, and decur and parsecs. I'm not quite sure what that is. This is obviously the spectral type of the star. So a lot of these stars, as you can see, are M.
If you go to the right on the table, you might be able to see more.
I don't see how to get over onto the right.
Yeah, mouse over it and hit the right key.
There we go.
There we
that's
go.
as far as it goes.
Okay.
That's as far as it goes. Anyway, so let's see if there's anything else here.
What kind of star is that? F2. F2II.
Yeah.
What does that mean?
An F star is a star that is slightly hotter than our sun. So our sun is a G2 star. I think it's a G2 or G5. I forget. And F is just one step back. So that is basically an indication of temperature, and the temperature of these stars is sort of an indication of mass and age and all that. So this object is probably much more massive than our sun. It might also be younger. So yeah, that's all that means. But there's some K stars in here, which are actually just a little bit warmer than M stars. So yeah, okay. Well, let's see. This is helping a little bit. Okay, so this is the velocity that it's leaving our solar system at, but why is that different? Here, the time from now, the star spacecraft separation, the relative velocity is the median. Is the median what? Is the median of the distribution over the samples? Okay. So this. Okay. Not quite sure if I'm understanding this table completely, but I think the takeaways are that these distances here in parsecs are sort of the closest approaches, sort of the average closest approach. And Voyager 1 and Voyager 2 are, of course, going to be going relatively near Proxima Centauri because it's just naturally close to us. And in fact, all these stars, are relatively close to us. So you can sort of see that there's a little bit of similarity here too. You can see that Voyager 1 is passing by Proxima at about 1.072 parsecs away in about 16.7 thousand years. Voyager 2 is actually going to be passing closer to Proxima in about 20,000 years. Pioneer 10 is going to be going by Proxima also in about 34,000 years. And Pioneer 11 is going to be going by Proxima in about 18,000 years or so. But some of these are getting way out there. For instance, in 3.4 million years, Voyager 1 is going to pass by, well, about a light year from this star, which just has a number. That's probably
that's if nobody captured it. And
exactly. But you've got 3.4 million years to figure that out. So I think you should get on that right away.
yeah.
This number is probably just a Gaia number. It's just a star. In fact, what we can do, we can go over.
Either a long number or a strange name for stars, huh?
Yeah.
You guys
astronomers like our weird stuff.
That's what Mark D'Antonio was talking about that.
Yeah. Oh, I think I need to. Do a. Is it? Oh, I forget. Hold on. Let me. Is it? Yeah. Okay. So it's Gaia, DR2, and then that number. Let's see if that star pops up. Oh, it doesn't. Well, that's not very nice.
How rude!
How rude. Well, it.
I don't know, but I'm looking for. But I know Fran, but he's from. He's at Utah right now, studying Russian. And actually knows the Russian language.
Oh, that's cool. 8, 12.
Japanese, no.
16. So there's 19 numbers there. There's supposed to be 19 numbers. Let's see if there are. So there's 4. There's 8. Oh. There's 12. There's 16. Yeah, there's 19 there. But yeah, for some reason that particular. Let's see if DR1 just for fun. Oh, I messed that up. Let's see if DR1. It's not coming up at all. We could probably you got to be stubborn about these things sometimes. Let's just go over to Gaia itself and look for that particular number. Let's see if we can get any information about that. Just some basic info. It's a K5 star, so that's gonna be probably pretty bright. Let's see. Can we do this? Can we just do that? Not resolved. Yeah. How do we? That's kind of an interesting thing.
Saying no.
Yeah.
How the heck they got this number anyway? If we can't pull it up.
Well, that's exactly what I'm trying to find out. So,
go back and make sure you got the number.
Yeah, well, I mean, I just did a copy and paste, so I mean, I shouldn't have to think too much about this. The one thing that I've never tried to do on the Gaia database here is actually look for an individual star. This is the first time I've done that, and it's a total fail. So,
you're gonna have to get that right for tomorrow, then.
Yeah, I'm trying to see if there's a. Yeah, see, because this is talking about position, and we don't really care much about the name here. Yeah, I don't know. Anyway, so that's going to be happening in a mere 3.4 million years. In 487,000 years, close encounter with this guy. And then 44,000 years. So I don't know why they don't put this in order.
In order, yeah.
Yeah, Not exactly sure. There doesn't seem to be any kind of order to this whatsoever.
16.7, 44 point, or 22 or 20.3, and then so forth.
Yeah.
So
Anyway, it's kind of interesting. You know, there are some similarities, right? Proxima Centauri.
what are they gonna do when they go by these stars? Are you gonna take the readings and
Nothing. These things are going to be.
they'll be dead?
They're going to be. They are going to be dead.
We're not gonna be available to observe the science.
Well, you know, maybe not specifically you and I, but hopefully, you know, I mean, in 3.4 million years, you know, if things evolve, then something's going to be here.
Yeah.
But yeah, no, I mean, this is
Earth
just
radio. Earth radio will be here.
Earth radio may
Yeah.
very well may be here still. Yeah, absolutely. So let's see if one of these other ones. I'm just, you know, I'm sort of a stubborn guy here, so I wanna see if we can get something here. Let's look at this one. Oh, can't get that one either. I don't know.
It's got to be listening.
Why do you put like more than 16 numbers and stuff like that? That's what's getting that's what's getting us all messed up at.
Yeah, you know, I'm not exactly sure what the naming convention is or numbering convention is for Gaia.
Yeah, they should tell you about that.
Well, you got to look at the you got to look at the documentation for Gaia. I'm sure there's an explanation as to why, you know, that star has that designation. And
we can't see it.
Yeah, well, for some reason we're not able to find it. I don't know why. I'm not exactly sure why, but I think it's kind of neat that you know, this to me seems like maybe it's like an undergraduate student or maybe a grad student that doesn't have much to do or something. Let's see, Max Planck and JPL. So, but yeah, I'm thinking that, you know, that is just sort of a fun exercise, you know, to go through. You know, you've got this absolutely stupendous database. So
I think we still got about a few billion years before they bake us. Before the sun bakes the Earth.
Yeah. You know, it's we should actually start seeing the effects of the evolution of the sun in about 200 million years. so you know, you got to make your plans now.
That's right.
Because that is right around the corner.
That's right.
Right around the corner.
The end is near, they say.
Yeah. So, all right. Well, here, wow. So they've got a few other little things here. So yeah. Voyager 1 is going to fly by this guy closest, TYC 3135. Yeah, and it's only about a light year away. And that looks like the smallest number here. Oh, no, there's a smaller one here. Pioneer 11 goes by this star at a little bit less than a light year, I think. Very cool. Yeah, Ross 248 is a relatively nearby star. We can actually look at that. We should look at that at some point. That's kind of a cool star. I think we just looked for that one, right? And it's not there. 3856. Oh, no, that's a different one. Let's see if that one's there. Is that one? Let's see if we can be lucky with this one. I'm not too surprised that it's not in Sinbad. Sinbad doesn't look like it's absorbed all of Gaia yet, and that's why we're not able to find them this way, at least. So I'm going to have to figure out how to find individual stars using the Gaia.
The archive, the Gaia archive.
Yeah, the archive here. So I'll have to look into that a little bit. So yeah, we'll figure that out. So let's see.
Should be able to just paste it.
Yeah, I'm not going to do it now. So Pioneer 10 is going by HIP 117795. What is that? Pioneer 10? Where's Pioneer 10? About 90,000 years or so. So mark your calendars for that. And let's see, Pioneer 11 is going to get relatively close to this guy, TYC 992. Oh, a mere 928,000 years. So yeah, I haven't heard anything to the contrary about. Oh, I got a doggy alarm. I don't think that these spacecraft are going to necessarily deteriorate in any way.
Or it's going to be billions of years before they do.
Yeah, space is also very, very empty. I mean, there's a lot of stuff.
You wouldn't be surprised if a Klingon would just shoot it down, like they did on Star Trek V.
Yeah, you never know. You never know. So that could happen, and that would be a sad day. But I don't think that we would know about it anyway. So, all right, everybody. Well, I'm noting the time, and I think it's about time to get on out of here for now. It's always really, really fun to just sort of share these kinds of things with you all, and not unnecessarily trying to teach anything, or we're just following our noses and seeing where it leads us. So yeah, these spacecraft that we are flinging out into the universe. New Horizons, right, is one of those spacecraft that's actually still operating, of course. And actually, I just heard a talk from Alan Stern a couple of days ago, and I think they are predicting that New Horizons should have enough power to be operating into the late 2030s. So that's not bad. I wouldn't be surprised if it's even longer than that. So they're not going to be able to maneuver around or anything, but they'll have enough power to run all the instrumentation, send all the data back, get commands, all that. But they are currently looking for a new target, right? They actually want to be able to fly by one more object, at least one more object. And they're actually going to be using the telescopes right on the spacecraft to look for these things. You know, they're going to look forward and see if they can see anything, because they New Horizons actually will have a better view of those objects from there than we do from here, right? Because it's closer. So very, very cool, very cool stuff. But New Horizons eventually, you know, I mean, it's zooming out, and it too will, you know, continue to zoom out. But you know, they may change their course. Like if they find something, you know, they want to get to it, they got to change their course a little bit. So, you know, doing a linear extrapolation out right now isn't a good idea, because, you know, the course is probably going to change. So, so yeah, we've got at least those 5 spacecraft that are on their way out. And of course, Voyager 1 and Voyager 2 are sort of technically sort of out of the solar system at this point. That's sort of a hard thing to define, but I believe that they've both passed this thing. It's called the heliopause. It's the that's where the solar wind first encounters the interstellar medium, right? You know, the stuff between the stars. So that's at least one of the edges of the solar system. So they are sort of technically out. I don't think that either the Pioneer are that far out yet. They are moving a little bit slower than Voyager. You know, so Voyager actually passed them up, and I think New Horizons. I don't think New Horizons is the fastest. I think Voyager 2 is the fastest still. So I think it's always going to be in the lead, but I think New Horizons, because I think it's going to pass everybody else up except Voyager 2. But again, you know, we're talking, you know, thousands and thousands and thousands, millions of years. So yeah, you know, it's possible that you know, a Klingon bird of prey could be flying around and encounter Voyager 2 and use it for target practice. Who knows? Who knows? All right, everybody. Well, I'm going to get out of here for now. So thanks for coming in again. Have a great evening, a great day. Make sure to subscribe if you haven't already. And hit the thumbs up if you like. And I think that's it. Share this around, spread the word. And I will be back here again tomorrow, 2 hours UTC, talking more astronomy, space, nerdy things of all sorts. Tangents are allowed to a certain extent. So you know, bring in your tangents if you want. And yeah, I think that's it for now. So take care, everybody. Live long and prosper.
All right.
Have a great evening, and I will see you. I'll see you next time. Okay.
See you all next time. Yep. Bye-bye.
Bye, everybody. Bye.